Hi, everyone. Today, my group will be presenting our chosen machine learning algorithm in the real-world scenario, which is weather prediction using hidden Markov model. Do you know what is the hidden Markov model? Hidden Markov models, named after the Russian mathematician Andrei Andreevich Markov, who developed much of relevant statistical theory, are introduced and studied in the early 1970s. They were first used in speech recognition and have been successfully applied to the analysis of biological sequences since late 1980s. A hidden Markov model is a statistical Markov model in which the framework being modeled is thought to be a Markov chain within hidden secret states.
Now, we will take a look on the advantages and drawbacks of this model. The advantages of this hidden Markov model are that it has a strong statistical foundation. It also has efficient learning algorithms where learning can take place directly from raw sequence data. The is a well-studied probabilistic graphic model, for which algorithms are known for exact and approximate learning and inference. Are able to represent the variance of appliances' power demands through probability distributions. Capture the dependencies between consecutive measurements, as defined by Hart as the switch continuity principle.
Here are a few drawbacks of the HMM model. The HMM often have a large number of unstructured parameters. First-order HMM are limited by their first-order Markov property. They cannot express dependencies between hidden states. Only a small fraction of distributions over the space of possible sequences can be represented by a reasonably constrained HMM. Consider two friends, Alice and Bob, who live far apart from each other and who talk together daily over the telephone about what they did that day. Bob is only interested in 3 activities: walking in the park, shopping, and cleaning his apartment. The choice of what to do is determined exclusively by the weather on a given day. Alice has no definite information about the weather, but she knows general trends. Based on what Bob tells her he did each day, Alice tries to guess what the weather must have been like. Alice believes that the weather operates as a discrete Markov chain. There are 2 states, rainy and sunny, but she cannot observe them directly, that is, they are hidden from her. On each day, there is a certain chance that Bob will perform one of the following activities, depending on the weather: walk, shop, or clean. Since Bob tells Alice about his activities, those are the observations. The entire system is that of a hidden Markov model, HMM. Alice knows the general weather trends in the area, and what Bob likes to do on average. In other words, the parameters of the HMM are known. They can be represented as follows in Python. In this piece of code, start probability represents Alice's belief about which state the HMM is in when Bob first calls her. All she knows is that it tends to be rainy on average. The particular probability distribution used here is not the equilibrium one, which is given the transition probabilities, approximately, rainy, 0.57, sunny, 0.43. The transition probability represents the change of the weather in the underlying Markov chain. In this example, there is only a 30% chance that tomorrow will be sunny if today is rainy. The emission probability represents how likely Bob is to perform a certain activity on each day. If it is rainy, there is a 50% chance that he is cleaning his apartment. If it is sunny, there is a 60% chance that he is outside for a walk. HMM has been successfully applied to problems including speech recognition, computational biology, and others. In this presentation, we choose to explain about the uses of HMM in weather prediction. Related work has been done in predicting weather using various techniques over a few years. An effort had been made to foresee draft using standard precipitation index. Apart from it was also tried to predict rainfall. However, in both researches, one thing was common, and that was the use of hidden Markov model. One of the methods to do a weather forecast is called analog method. It's about examining the past state that is the same with our current state and forecasts the weather based on what happened in the past after this state. So, it's perfect to use the Markov model to apply the analog methods to forecast the weather. Hidden Markov models are used as a representation of a problem space in which observations come about as a result of states of a system, which we are unable to observe directly. These observations, or emissions, result from a particular state, based on a set of probabilities. Thus HMM are Markov models, where the states are hidden from the observer, and instead we have observations generated with certain probabilities associated with each state. These probabilities of observations are known as emission probabilities. Formally, a hidden Markov model is a 5-tuple, which consists of the following parameters: a series of states, labeled as Q, a transition matrix, a vector of initial state probabilities, labeled as P, a set of observation symbols, labeled as V, a matrix of emission probabilities, labeled as E. The key property of memorylessness is inherited from Markov models. The emissions and transitions depend only on the current state, and not on the past history. As a conclusion, hidden Markov models have become one of the most widely used tools in weather prediction. In this presentation, we review the HMM and its applications in weather prediction. It has to be noted that this review is by no means exhaustive, and that there still exist many other types of HMM, and an even larger number of sequence analysis problems that have benefited from HMM. Hidden Markov models provide a sound mathematical framework for modeling and analyzing, and we expect that their importance in this climate forecast, as well as the range of their applications, will grow only further. Thank you very much for your unwavering attention throughout this presentation.